Good morning to all my dear students. Welcome to the another interesting lecture on the topic elements of the first transition series. We have discussed in the previous lecture the elements of the first transition series, that is 3D series, which contain 10 elements. We have also read its important characteristics like electronic configuration, oxidation state, complex tendency, catalytic behavior. We have also read about the periodic properties like atomic radii, melting point, boiling point, reducing property, along with its trend. Now we should learn about the chemical property of this series, in which the binary compounds of the first transition series. So what we have read in the previous lecture, that are the prerequisites required for this lecture. The student should have the knowledge about the first transition series along with their important characteristics and the periodic properties. In this lecture, we should cover the following topics: the binary compounds of the first transition series, in which we first talk about the oxides, the reducing and the oxidizing power of the oxides with the examples sulfides, halides, and carbides. Binary compounds should be discussed. What will be the learning outcome of this lecture? The students will be able to understand about all type of the binary compounds of the first transition series along with their properties and its uses. So let's understand what are binary compounds. Those compounds which are formed by the combination of the two different elements or the ions are called binary compounds. The first transition series or the 3D series form many types of the binary compounds with the oxygen, sulfur, halogens, carbon, nitrogen. It forms various binary compounds like oxides, sulfides, halides, phosphides, carbides, nitrides. The first binary compound is oxides. The elements of the 3D series react with the oxygen at the high temperature to produce oxides. These oxides are less basic and less soluble in water. The oxides in the lower oxidation state are ionic and basic. In the intermediate, the oxidation state, their nature becomes amphoteric. And in the higher oxidation state, ionic nature decreases, the covalent nature increases, thereby increasing the acidic character of the oxides. It means the acidity of a salt depends on the covalent character, which is based on the oxidation state of the element. So, the compounds oxides are formed at the lower oxidation state and their nature is ionic and basic. As the oxidation state increases and it comes to the medium or intermediate oxidation state, the oxides nature become amphoteric. And at the higher oxidation state, the oxides which are formed that has the covalent nature and the acidic character of the oxides it possesses. So we can say the oxidation state is directly proportional to the covalent nature is directly proportional to the acidic nature. For the remembrance, this you should know, okay? Of the first transition series, the oxide formation depend on the oxidation state, and higher the oxidation state, higher the covalent character and higher its acidic nature. And if we say that lower the oxidation state, lower its covalent nature, that becomes ionic, and lower its acidic nature, that is basic. So this is the main point to remember the oxide nature. Okay, so you go for remembering this oxidation state is directly proportional to the covalent nature and directly proportional to acidic nature. So on the basis of the oxidation state and the nature of the oxide which is formed, it may be classified into three types. The basic oxides, okay, the lower oxidation state elements generally form the basic oxides. The second one is the amphoteric oxides, and the third one is acidic oxides. The basic oxides are those oxides which are formed by the metals in the lower oxidation states. These are ionic in nature, soluble in non-oxidizing acids like hydrochloric acid. The example of the basic oxide is titanium oxide, chromium oxide, manganese oxide. Understood? And here is the ferric oxide, cobalt oxide, nickel oxide. So at the lower oxidation state, each one of the transition elements and their nature is basic because they are ionic in nature. Now if we talk about the amphoteric oxides, these are the oxides containing the metals in the intermediate oxidation state. So they have the medium oxidation state and they are also soluble in the non-oxidizing acids like hydrochloric acid. The example of amphoteric oxide is, again we have the titanium oxide, vanadium oxide, here Cr2O3, Mn3O4, MnO2, cupric oxide, zinc oxide. The acidic oxides are the weak acidic in nature and are formed by the elements at the higher oxidation state. And these are soluble in bases. So we have the V2O5, okay. The vanadium is forming the amphoteric oxide at the intermediate oxidation state. V2O5 is the higher oxidation state. We have the chromium oxide also, manganese oxide also, these two, they are the acidic oxides. Now let's understand the reducing and the oxidizing nature of the oxides we have seen. The electron exchange property determines the redox nature of the oxides. And what is the redox nature? It is the ability of losing the electron or gaining the electron. That is reduction and the oxidation. So if we see the oxide containing the metal in the lower oxidation state, act as the electron donor. So lower oxidation state can easily donate the electron. That's why that is a strong reducing agent or we can say reductant. Either we can say the reductant or the strong reducing agent means it has the ability to donate the electron. As the atomic number increases, the reducing property in the lower oxidation state also increases. If we see, this is the lower oxidation state, titanium oxide, vanadium oxide and chromium oxide, and compare its property of the reducing agent. So we can say the titanium has the lower atomic number, then the vanadium higher atomic number, chromium is higher atomic number. So if the atomic number goes on increasing, it has the ability to donate the electron. It can easily donate out the electron. And if the metal in the oxide is in higher oxidation state, the oxide is electron acceptor, like we can say the chromium oxide, the manganese oxide, and it acts as the strong oxidizing agent. So the reducing nature, the oxidizing nature depends on the lower or higher oxidation state of the first transition series. Understood? The lower oxidation state oxides has the ability to donate the electron, that is strong reducing agent, and the higher oxidation state oxides has the ability to accept the electron and act as the strong oxidizing agent. So the first oxide of the first series, we are taking titanium dioxide. So let's see its method of the preparation and the properties. It can be prepared from the red hot titanium chloride when react with the steam. It produces the titanium dioxide and the hydrochloric acid. It is a very important oxide to be used at the industrial level, as well as we can say as a white pigment it is used. The properties are the white amorphous powder, and it is highly bright powder. It becomes yellow colored when hot, insoluble in the water, hardly soluble in the acids. If we talk about its property, and it can easily reduced by the carbon at the high temperature. So here you can see the reaction of the reduction of the titanium from the titanium dioxide through the carbon. Understood? So here we have the reduction by the carbon. So it gets reduced by the carbon at a high temperature. So many of the uses are there of the titanium dioxide. Let's see. The variety of the uses of the titanium dioxide is there. It is used as a white pigment because of its brightness and the high refractive index. It is used as a white pigment. In the glass industry, in the cosmetic industry, it is used to prevent our skin from the harmful UV radiation. So it filters out the harmful UV radiations. So main role of the use on the cosmetic industry is acting as a sunscreen, as well as for the skin brightening. It is used in the various lotions, used as the rubber softener in the rubber industry to prevent the brittleness, the cracking and the fading of the product. So in the many industrial use of the titanium dioxide is there. The second oxide, that's the zinc oxide of the series. It is also amphoteric oxide. It occurs as a zincite ore in nature. So let's see its method of the preparation. There are the two methods of the preparation of the zinc oxide. The first is it is obtained by burning the zinc vapors in the oxygen. So you can see here when the burning takes place of the zinc vapors in the oxygen, it produces the zinc oxide. It is also obtained on heating the zinc carbonate. Understood? So here you can see the zinc oxide is formed and the carbon is also formed. Let's see its properties. It is the white amorphous solid. It becomes yellow on heating and white on cooling. It is reduced by the carbon monoxide. Here you can see the reduction reaction. Here the zinc goes on reducing and the carbon monoxide is oxidizing. So the variety of the uses of the zinc oxide is there. It is used as a ointment, antiseptic ointment, because it is having the property antibacterial, deodorizing property. In the rubber industry, it is used to protect the rubber from the fungi and the UV light. In the ceramic industry, due to its high thermal conductivity and the high temperature stability, it is used to prevent the skin from the acne, rashes. So as a medicine of the skin, it is used as a baby powder. So the next binary compound is the halides. The 3D transition series react with the halogens at the high temperature to form the halides. And the reactivity of the halogens goes on decreasing from fluorine to the iodine as the reactivity down the group goes on decreases. The fluorides are ionic. The others have the ionic as well as the covalent nature. The halides are formed by many of these elements in the different oxidation state. You can see here the different oxidation. Titanium chlorides are there, TiCl3, TiCl4, vanadium in the different oxidation state. So that is +3, +5, +3, +4. The third binary compound is the sulfides. The metal sulfides may either be prepared direct heating the mixture of the metal and the sulfur, or by treating the metal salt solution with the hydrogen sulfide or sodium sulfide. So it can be prepared by these two methods directly, as well as the mixture of the metal salt solution when treated with the hydrogen sulfide or sodium sulfide, it produces the metal sulfide. So these are the two methods. It is the direct method directly react with the sulfur to have the metal sulfide. The metals in the low oxidation state form the sulfides, which are insoluble in water. The lower oxidation state sulfides are insoluble in water. The next binary compound is the carbides. The metal carbides are generally prepared by the two methods. Directly, when the metal reacts with the carbon and it goes on heating it, it produces the metal carbides. And the another method is it is prepared by the metal oxide. When heated with the carbon, it produces the metal carbide. So as same as the sulfides are there, the carbides can be also produced by the two methods: directly the carbon heating to the metal, or the metal oxide when heated with the carbon, it produces the metal carbides. Now, according to the nature of the metal carbides, we can divide or classify the carbides into two types on the basis of the nature. The one is salt-like carbide, which are, we can say, ionic in nature. Understood? And the another one is the interstitial or the metallic like carbides. So let's see the carbides of the scandium, copper and zinc, which are ionic in nature. They are called salt-like carbides, and it is produced by, here you can see the method of the preparation of the scandium carbide. So it is heated with the carbon. This scandium oxide, when heated with the carbon, it produces the scandium carbide and carbon monoxide. So this is the salt-like carbide. And we have the zinc carbide. When heated with this acetylene, it produces the carbides, which further hydrolyzes to form acetylene and zinc hydroxide. So when it undergoes the hydrolysis, it produces the acetylene, and which goes on producing the more carbides. So these all are the salt-like carbides. The next carbide is the interstitial or the metallic carbide. As we can understand that this type of the carbide have the metallic properties. So these are the hard solids, have the metallic properties like luxure, stable at the high temperature, chemically inert, and are conductors. Nickel does not form the carbide. In the solid state, these have the tetrahedral or octahedral voids, which are occupied by the carbon atoms. So that's why it is named as the interstitial, because these are having the tetrahedral or the octahedral voids. And in the voids, which is occupied, carbon is occupied here. So vanadium carbide, titanium carbide, here the iron carbides, all are the interstitial or the metallic carbides. So we have understood all types of the binary compounds which are formed by the first transition series, and we can compare it with the method of the preparation and its properties with its uses. You have seen a variety of the oxides of the first transition series having a certain application in the various industrial purpose, as well as a medicinal point of view. You have seen the role of zinc oxide there. So the carbides, sulfides, halides, these all are the binary compounds which are formed by the first transition series. In the next lecture, we talk about more chemical properties of the first transition series, like complex formation, how the complex is formed by the elements. As we have seen, it's an important characteristic of the transition elements. These are the references of the inorganic chemistry. We have the concise inorganic chemistry by J.D. Lee, chemistry by the M.M.N. Tandon, Even we can have the reference of the O.P. Tandon chemistry book. Thank you and take care.